Did we just prove alien life? If we didn't, hang around and hear why you'll see proof in your lifetime. How do you prove alien life? With biomarkers. Biomarkers are chemicals that are only produced by the chemistry of life. Find a turd in space, you found life. Find some gaseous oxygen on another planet, you found life. But where do you look for biomarkers? On exoplanets that orbit alien stars. In the red corner, weighing in at a whopping 8.6 times the mass of the Earth, and with an explosively hydrogen-based atmosphere surrounding a planet-spanning liquid water ocean, possibly teeming with life, nicknamed the biggest scientific tease since the black hole. Give it up for K2-18b! K2-18b was recently observed using the James Webb Space Telescope, the collective science fair project of about 300 universities, organizations and companies over a cheeky 14 countries. It's a big camera, very big. Oh, and the lenses are yellow because they're made out of gold? But back to the point. To prove aliens, you must find their biomarkers. To find biomarkers, you must find and study life-suitable planets. Now, finding planets is hard because we use cameras which image light. So, they're great for looking at light-emitting stars, nebula, galaxies, etc., etc. But planets are dark things. To make it worse, they orbit the brightest objects in the universe, so lens flare is pretty rough. But the lab coats have a great solution. It goes like this. Notice how the moon passing before the sun blocks light? So, if we drew a cheeky graph of the intensity of illumination during an eclipse, we would get a dip. Great. Now, point your big old space camera at a distant star and wait to see if the same thing happens. If there's a dip, wait for it again. If it keeps happening, that means something is regularly passing before that star, maybe a planet orbiting it. This detection method is called transit. Last month, there was a possible identification of a biomarker on K2-18b called dimethyl sulfide. In the whole known universe, this chemical is only formed naturally on one planet, Earth, by the metabolism of phytoplankton. If this possible identification is verified, it might be the greatest scientific discovery of human history. The question, are we alone in this universe, will finally have been answered. In a moment, I will explain why, even if this identification fails, you will see proof of life in your own lifetime. But first and briefly, some hectic astronomy. Because a planet is too dark, and its sun is too bright to look directly at a planet, the lab coats have this neat little trick called transit spectroscopy. As a planet passes directly in front of a star, some light refracts through its atmosphere. The spectrum of light we collect from this is stacked with the little signatures of chemicals who block tiny little bits of the spectrum. Here is K2-18b's spectroscopy data. Just a reminder that this is a literal alien atmosphere. That right as you're watching this video, it is blowing little stones around and roiling ocean waves into a fury. This stuff is insanely real. In the last 35 years, the number of exoplanets we have found has jumped from a massive 0 to over 5,000, with another nearly 10,000 waiting for confirmation. Oh, and here's the photo of the first exoplanet that we ever found. The point is, the telescopes we have launched in the last 35 years have all represented massive technological and methodological improvements that compound on each other. In addition, the Drake equation, which is a statistical model for alien life, suggests that if life emerges on just 1% of Earth-like planets, our nearest alien neighbours would likely be within just 250 light-years. But what if life emerges on more than just 1%? The point is, it's just a game of numbers now. We have the tools and we have the techniques. Now is the age of discovery. So strap in and wait. It'll be our generation that answers the question.